And I would hope that everybody sees what is on my screen, and we will base the discussion on what is on my screen. So I'm going to share my screen, application window that, am I right? Perhaps I picked the wrong file. Okay. All right. Can you all see my screen?
Yes,
Yes,
sir.
we can. Thank you.
Okay. So I'm going to start from week 5. If there is any part of week 4 you did not, maybe you didn't treat it or did not catch up on it, we're only going to come back to it at the end of the lessons. So today, I hate to say this, I was trying to run away from this lesson because I have my hands full. Now I have canceled another lecture I was supposed to be having, the one for BCom IM, and I was persuaded by the national to take this on. So yeah, that is how it worked. So today we're going to be looking at systems acquisition. There is A missing there. Should be letter A missing there. I don't have the tool here again, but anyway, system acquisition and development. In this study unit, hopefully you should learn about tools and processes that enable users to manage data that can be also used to uncover new insights and make effective decisions. But the key to the chapter is you should be able to identify the pros and cons that are associated with both buying and building a software. Somebody seems to be okay. Um, from what I understand, I'm supposed to have 81 of you on this platform. So far, let me see how many I have. Oh, goodness me, so few of you here. And Bianca, you're welcome. I knew you couldn't miss it. Um,
Thank you, John.
Thank you. I'll just wave. Let's put up my video for a short while and wave to everybody. Yeah, yeah, you can see my face. Yeah. So I turn it off again. All right. So let me go back to what we were discussing. So now you should be able to identify the pros and cons associated with both buying and building software. You should be able to apply knowledge of administration of this business function to a hypothetical scenario. Not much about the second part. See, I like skipped it somehow. Then you should be able to identify the advantages and disadvantages of the waterfall approach to systems development. Now, if it was a physical class, I would have wanted to ask, and I can still ask this question. How many of you here on this platform understand what system development is about? If you have, if you know, please indicate by raising your hand. I need to see a hand up. System development. Anybody? Okay. Pierre understands that. Who else understands that? Oh, Bianca, don't tell me you don't understand what the system development is. Thank you. Thank you for, yeah, for indicating. Michelle, okay, good. Tobela, looks like Tobela is out of it. Okay, Tobela, I'd like, and Michelle indicated who is this LC? Pardon me, I really need to try as much as possible to get everybody participating. Tobela is set to indicate. Is Tobela really active? Please, Tobela, if you're active, I need to see the indication. Okay. Yeah, my question is, do you understand what system development is?
I think I do. I thought maybe one of the guys who do understand can remind me.
Come again. Do you understand it or you do not understand it?
I'm saying I think I do, but I thought one of the guys who raised their hand in understanding them might just remind me when.
Remind you? That would be stealing because then I wouldn't be sure you really understood it because you're just going to agree with them. Yeah, it's natural. You just agree and then we see us all move on. But anyway, Michelle, I need your indication. Michelle? I hope it's not one of those. Yeah.
I think so, as far as I'm concerned, it might be just a process of defining and probably designing and testing. I think that's the essence, I think.
Designing, okay. Designing and testing what?
An application.
An application. Oh, very,
Yes.
very good. Very well, very well, very well. That's quite interesting. You know, it's important to put everybody's mind to come to what we're discussing. Okay, and it's really very important for this topic because now we're treating what? Systems acquisition and development. So now the understanding of what systems, okay, what do we mean here? It's very key to whatever we are going to try to build. I think there is somebody else who's trying to come or go. I'm not sure. Okay. So Mike Besa on hold. Okay, well, I'm just going to ignore that for now. So now we are discussing here systems development. And the best way to relate to this is to cast your mind back to one point. An example, you are developing a software application for your organization, for your company, or for a company. Now, the approach this time is it's a way that it is approached from both you being a member or a part of the company. It is more you are viewed as somebody who is the part of a company, of the organization, of the enterprise, more than you are an external person serving the company by developing such a software. Okay, so with that, if you wrap your mind around that, then we are able to better understand what we're going to be discussing here. So here we have identified the advantages and disadvantages of the waterfall approach. So you're going to see waterfall approach to system development. Okay, your mind should go. That means, of course, there may be several approaches. You may have learned a bit of it from your information systems 1A, okay? And perhaps a little bit of it, no, you wouldn't have done that in networks, it's not discussed there. But in your information systems, you may have had a bit of hints to this. And again, because you've done programming 1A, you have actually developed some software, snippets, okay? Little software here and there. So now, if you must have been told by your lecturer that the software, the examples you use, the software you developed as maybe tests or assignments, they are just like a copy of what you would need to do in the real world. An average software will comprise of what you developed, multiply that by 20 to 30 or sometimes 100 times, whatever you did as assignments, as test and exam, whatever you did in that programming, you may want to multiply that by maybe 100 or even 200 times or maybe 1,000 times. That is all the work you have to do to develop a software program, an application for a company. If your mind goes to such a big project, then you can better appreciate what we're discussing here. Because if it's the simple examples you did, like, the exams you wrote, the tests you wrote, you realize that in 30 minutes, 40 minutes, you were able to develop a whole code. And usually it was just a small task, okay? But what we're discussing here is systems development process that involves, for example, developing an application that may be around 100 to 1,000 times what you did in your test and exam. Okay, maybe for the assignment could be like 200 times to 500 times what you did in the assignment. So if you put your mind to such work and then you imagine, okay, it took me so much time to complete this assignment in programming 1A, then for a typical application, and I am saying to you that it might be 100, 200, or 500 times. So you then have to multiply how much time and effort that you put to develop that assignment, multiply it by 500 times. And that is the kind of, system we're talking about here. So you're able to well appreciate it. So now there are approaches to developing such a program, such a software. So here, what you're supposed to understand along the line is identify the advantages and disadvantages of the waterfall approach. That means there is an approach called waterfall approach to system development. Again, you should be able to identify and state the goal of each of the 6 phases of the waterfall approach. Now, more is coming out. Just trying to tell you that the waterfall approach has 6 phases. Okay, you're going to understand as we go on how do these phases, relate to each other. Identify and briefly describe the primary tools and techniques used during systems development. We're going to look at that. Define 5 types of feasibility, very important. Oftentimes, I tell students that I even told students earlier in the day the same thing today, that when you attend classes, you more or less have studied. You are like 50% ready for any test or exam, because in the process of attending classes, you get to hear some key points, some things that are relevant for your exam, as well as some things that if you were going to be reading alone or by yourself was going to take you like maybe 2 weeks or a month, or you may never not really understand it. But when a lecturer is talking to you and you listen and then hear what he or she is saying, somehow you're able to pick understanding to what is being discussed faster. And by your understanding it within that short time of the lecture, when you're reading, you see yourself reading and studying with greater understanding. And you spend less time trying to decipher what has been put in your study guide or even from the textbook. So now what I'm pointing out here is, see here it says identify and state the goal of the 6 phases of the waterfall approach, the primary tools and techniques used during systems development, and now emphasized again 5 types of feasibility that must be accessed. That means there are some feasibility that has to be assessed, and then there are 5 types of feasibility that must be assessed in the process of developing any application. There are 5 of them. We're going to discuss that, and we should be able to identify the purpose and participants involved in various types of testing. Then you now have unit testing to user acceptance testing. Now, let me go back to this place because it also helps us when I get there. I don't have to overemphasize it. Feasibility. Can somebody who will has this statement that says types of feasibility, can somebody tell us, or let me ask a question. Can you picture, is everybody able to picture what we mean by feasibility here? Feasibility.
If I had to take a guess, it refers to while developing and figuring out what you're building, what's the budget? How feasible is it financially? What are you solving? Is it practical? What, like, can it be achieved in the time frame that is presented, or the lead time that you need to complete it in? And do you have the manpower to do it? I guess resourcing. How feasible is it to achieve it?
Okay, that's interesting. That's really very interesting. Now the only unfortunate part is I'm not able to access everybody's countenance. Um, who else understands it that way? Anybody else? Bianca, stop being silent or quiet here, Bianca, please.
I don't understand.
You don't understand?
She's lying to you, John.
Is she lying to me? Okay, I believe you. She's lying because I would have been surprised if she does not understand it. But anyway, the feasibility, like what you've done, here, I guess I believe I'm calling it right, peer, right? Okay, what you've explained is actually the technical content of feasibility. In your explanation, you've actually, touched on some of the feasibilities, one of those, about two of those 5 feasibilities that we mentioned, okay, that is necessary to be considered. It says 5 types of feasibility that must be accessed. Okay, we go again, the purpose of, identify the purpose and participants involved in various types of testing, from unit testing to user acceptance testing. Identify 3 approaches for system cutover. So you begin to say, okay, wow, approaches for system cutover. Then your mind will go, what is cutover? You're going to be thinking, what is cutover? Now, then before you come to even attach system cutover or system to the cutover, we're going to treat that. And then describe the agile development process. What is this agile development process? Now, see what this does to you as you're, taking the overview. It creates question in your mind. If we have all the time, that's often what I would like to do. Create a question. So as the answer comes, you have a memory, prepared to receive the answer and return it. We're going to look at the advantages and disadvantages of the agile system development approach. So now, when the question, for example, says, discuss 2 approaches that may be used for systems development. Discuss 2 approaches that may be used for systems development. So far, if anybody knows the answer, let me see your hand up. Okay, not at least, okay, mention 2 approaches that may be used for systems development. If you know the answer, just let me see your hand up. Indicate by putting up your hands. Okay, Bianca is there. Nobody else? Name 2 approaches that may be employed during systems development. Just name the approaches. Aha. The people are silent. Okay. It does seem to me perhaps you didn't hear me. Let's come back to what I hate to see my screen.
I guess agile is one of them, and the other one could be unplanned.
The waterfall approach.
Did you see waterfall? And I was overflowing it here. Waterfall. Advantages and disadvantages of the waterfall approach to system development. That's one. And then over here, we're seeing agile. Is somebody following now? So far, we've seen 2 methods of systems development. One is waterfall, and the other one is agile. Do we get it? Seems somebody is trying to come in or trying to go out. Yeah, please confirm to me, do you get what I am presenting?
Yes.
There's waterfall and there is agile that you see. Now, you see, now this is what I try to say. You know the answer. A lot of times students know the answer, but because you're trying to figure it out, okay? And perhaps because you did not think in that direction, you did not think through such a question, so it becomes like a mystery to you. So like I just asked now, just name two approaches to systems development. We've seen the first one that says waterfall approach to systems development, and over here we're seeing agile approach to this agile development process. So we have already two approaches to systems development. Okay, the waterfall and the agile. And if you think through deep, you may be able to come up with the other one, and that usually happens with project management, where we say traditional method. But let's stick to what we have on paper now. There are two of them we can see so far, the waterfall and the agile. So we should be able to identify three approaches for system development. I keep getting that sound. I guess nobody is trying to come in. Okay, pardon for that. All right. So next is describe the role of the Scrum Master and product owner in the Scrum framework, and then discuss extreme programming, XP, and DevOps. More importantly to me is XP. More important to me is the XP. So now you see where we are going to. So let's try to see how much we can cover before the time runs out on us. Okay, in continuation, we are to outline a process for evaluation and selection of a software package. Evaluation and selection of a software package. And then finally, you should be able to identify the key factors to be considered in selecting a software package. Now, usually I encourage students to try to, if you had a physical copy of the study guide, when you see where a lecturer has highlighted, it will make sense that you also highlight it, okay, because it becomes pointed to you on the point on the part of the study guide that was emphasized. So, I mean, if you're going to read this 96 page of work, it's not everything that is relevant for the exam. Granted, in the discussion, I'm going to discuss things that are not examinable, but still useful, which is part of what you're supposed to learn, because we can't possibly examine you on every single line of text in this study guide. Okay, so a lot of things I'm going to say maybe will not be examinable, but still knowledge that you need to acquire. And a lot of things also will be things that you need to prepare for because they are very examinable. Okay, so we get a start. Buy versus build. This is with respect to software acquisition. The buy talks about a situation where a company decides to go out and buy the software for their use. Okay, it has its advantages and disadvantages. And if I know if I open it to the floor to try to give me some, advantages that a company might gain by going out to buy the software instead of building it themselves. Yeah, and I'm going to ask that question. Please, is anybody confident enough? Just think about it. If a company goes to buy the software against making it by themselves, what advantage do you think they will gain?
I think that if a company buys a software, they will get the expertise of a company that is dedicated to software building and its complex functions that it builds, and also to a much more experience and a much more working environment. rather than if they build it, then it will also take them time and effort, and maybe it will not turn out to be as they think it will. But for
Okay.
the buying part,
Mhm.
it will give us a better end on that perspective.
Okay. Can I get another contribution? You all heard what he said.
Yeah, I think I agree with Ahmed. Buying's advantage is that at least that company which is going to or has developed that application has already worked through the bugs, some of the bugs, and by selling it, one, it's availing itself to support that application. And rather than developing an in-house application, which one needs to then work through the bugs as well, needs to support as well that application, which might also, depending on the company, might not be feasible, depending on the budget of the application as well. So that's my take on it. I think buying is better than in-house developing.
Okay. See, now you all can already understand that this is very practical, but then we need to filter through and see what the study guide tells us. What are, all the things that makes better sense. Okay, any more contribution to that?
In my opinion, when it comes to buying versus building, sometimes a customer needs a specific system to have specific requirements that a bought software cannot offer it. And that's why building the software will then be better in that circumstance.
Okay. Now, it's a good thing, even though I'm not able to sample the countenance, the um, contributions from everybody, but at least we get the drift, right? Okay, so let's see what we have in the content here. Buy versus build. Some companies continue to spend considerable amount of time and resources developing and acquiring software to support a wide range of programs that they use. Well, there are opportunities and problems that frequently trigger the initiation. Companies don't just sit down and they're thinking of what to do and they just, hey, like out of the blues, let's go and buy this software or let's make this software. There are, triggers, things that lead to, the acquisition of a software, either by buying it or making it. So we'll call that trigger that initiate the acquisition of such information systems. And some of these triggers will include, it's important to look at these points again. What are some of the triggers that will necessitate a company buying or making a software or buying or making an information system? Some of them include organizations may pursue opportunities to use information systems to support a key organization strategy. Now, this seems very big English, okay? It's just, the vocabulary might be too heavy here, to some people. When we say strategy, organization strategy, every organization has what they want to do, what they want to be known for. For example, we are Damelin College. What is Damelin College about? What are we known for? What does Damelin pursue? It is academic excellence. And you're not going to see Damelin pursuing academic excellence, and the strategy to pursuing it will be a strategy that makes us the best farmers in the southern part of Africa. Okay, that doesn't work. So you see, when we say a key organization strategy usually is wrapped around what does the company want to employ, tools, okay, functionalities they want to employ to achieve their mission and vision. Damelin is about academics, it's about education. So for a trigger for Damelin to want to acquire a new information systems is perhaps Damelin may see an opportunity, okay, pursue an opportunity to use that specific information system to aid what they want to be known for, okay? Best in academics, best private education, business establishment in the southern part of Africa. So to enhance that pursuit, okay, they might want to acquire a certain information system, okay, in today's world. Now I may want to tell you, or make everybody here know, 10, 15 years ago, let's say 15 years ago, the types of telephone systems that were found in Damelin colleges was the telecom lines. They had direct connection to the telecom line. Okay, but today, no Damelin college is using that anymore. All we're using now is actually, in the final analysis, we're using voice over internet in a lot of our campuses. So you see, instead of the normal telephone jacks that would usually have connected to telephones and the normal telephone jacks, the RJ11, you're in IT, you should get to some of these terms. The RJ11, which connected to the telecom lines, we're now using RJ45, which are network cables. So that gives the impression, gives the understanding that, the telephone calls made from Damelin colleges is no longer, the one that has telecom connection. Now, it's because of the advantage that this offers over the telecom connection. So as an example, there had to be a change from the telecom analog system to the now more modern digital system of telephone communication. Okay, so organizations one of the reasons or the triggers, or one of the things that trigger the initiation of an information system project will be one, where organizations want to pursue opportunities to use the information systems to support a key organization strategy. If it's going to help them support a key organization strategy, then they will pursue that information system. Number two, where there is pressure to increase profitability and improve operational efficiencies. This often drives organizations, companies, to implement new approaches and technology to increase profitability. If any company says that by employing a certain information system, a certain technology, they are going to have greater earning, greater profit, okay? I mean, example, if the company was using the old printer system, okay, that only printed a few pages per minute, okay, and now there are modern printer systems that will print out, a minimum of 22 pages in 1 minute. Okay, I mean, it will make sense to pursue such, because instead of having to wait the whole day to print a 500-page document, you see yourself running it out in less than 20 minutes. 500-page document is printed. Okay, so as long as it brings profitability, there is improved profit by pursuing or employing such information systems, then that would trigger, the acquisition of such technology. Another will be the availability of new technology. This can create an opportunity to offer new services or attract new customers. When the company sees that the available new technology, now this might be open to some arguments, okay, for those who are, savvy in this area, because somebody might say, is anybody making a request again. Oh, okay. My cursor is wanted to come in. Okay, now this third point, the availability of new technology. Now, the understanding you may want, I want to just make the students get here is there may be a new technology. There might be a new technology out there. And companies who are versatile, who are open to new things, they're always looking out for opportunities that exist out there. They might encounter a new technology, and after some investigation, they find out that it will improve their baseline. Okay, it will improve their customer service. Customers will be happier being served, with such new technology, and things move better than it was before. Companies would naturally go for it. Now, the customers may not know, do not have to know existing or maybe new technologies that are out there. All they want is service. All they want is whatever they need to be served with. And it has to be on time, the expected quality, okay? And so if there is a system that can help a company give it to customers better, faster, greater quality, then what customers will suddenly realize that is that perhaps when they went to the post office, for example, to renew their car license discs, they had to queue up for maybe 1 hour because there was always many people there. If for some reasons, when you get there and where there used to be queue, when you get there in 3 minutes, you're out. And you're wondering what happened. It used to be 1 hour here in the last 10 years. How come between last week, last month, okay, last year and now, I spent only 5 minutes in the post office, for example. Okay, now the customer may not know the technology that has been employed or may even see it as he or she is being served. That will lead to enhanced customer, service. Customer satisfaction will be enhanced. And what happens is such a customer would want to come back because he or she has the experience that he or she does not have to spend that much time as it was in the old days. Okay, so the availability of new technology, which can create an opportunity to offer new service or attract new customers. Obviously, in the sense of attracting new customers, in this case, old ones are returned. And part of what you're going to learn, I don't know if you're going to do e-commerce. What subject is that you're going to learn this? I think still in information systems, perhaps information systems 2A or 3A, you will learn that customers are acquired. Okay, and new customers are, part of advertisement for a company is that when a customer is happy with a particular company and their product and service, the advertisement you get is also from mouth to mouth, where a friend tells a friend that, hey, try these people, they're doing well, they're doing better. In that way, there is a wider reach. Newer customers are, are welcomed, are made to come to this company. Now, organizations can use several different approaches when developing their own software. You see, I mark this again in green. This is what I encourage you to do when you're in your study guide. Find a way to highlight these things. They are very beautiful and important pointers. Organizations can use several different approaches when developing their own software. Two of those are what? Waterfall and agile, like we discussed earlier on. Okay, below we have the advantages and disadvantages of buying versus building your own software. When you buy your own software, one of the reasons we've already highlighted it, a solution can be acquired and developed relatively quickly. An organization can test drive software before acquiring it if you are buying it. You just go to the market when you need it, buy it, and quickly put it to test, and then find out if it gives you what you want. The disadvantage here says unmodified. The software may not be a good match to an organization's need. it might meet it 60% or 70%. The other 30% that is left out might be more important to the company than the 70% that it is serving. Maintenance and support costs can become excessive because now you're depending on the vendor to maintain this software for you, which you didn't make, and also to support it. And so when you are now, what happens is you are at the mercy of this vendor. Think about a software. I told students in class once that, in the year 2001, in the year 2001, I think it was year 2000, I was working with a company, and the company bought a software, single license software, meaning that we could only run the software in one computer in the company, and it was very essential. We bought that software in 2000, I think 2000/2001. It was bought for $16,000. $16,000 was used in buying just one software. Obviously, it's not something that perhaps somebody might say, okay, if the producers of this software refuse to run cheap in their maintenance cost, I'll just give up on them, go use another company. If we did that, okay, left this company, if their maintenance cost was too much, we thought it was too much, to go for another company means that we had to go buy a different software, which may cost either close to or even more than $16,000. And so you see, when it says maintenance and support costs can become excessive, now you see you don't have a choice. You are like, you're blackmailed. You don't have any other help. You just must continue to use these people who sold the software to you. I guess somebody is listening. So as much as there's so much advantage in buying software, you also may be exposed to this condition where you are, okay, held at ransom. You are completely dependent on the vendors to maintain and support your software. For the build, yeah, advantage is that you have customized software that captures all the company's needs. You're not going to build a software that doesn't capture all it needs to do for the organization. A custom application provides the potential to achieve competitive advantage. Clear, it cannot be overemphasized. On the flip side, the issue here is that building it internally might be too expensive. The cost to build the system can be quite high compared to that of buying it off the shelf. Now, those who are selling it off the shelf, what they've done is they've spread the cost of developing it across the many copies they're going to sell. Okay, and so it becomes cheaper. Whereas if you were to build it yourself, you are going to bear that cost all by yourself. I mean, developers are not cheap. And if you have to keep 4, 5, 6 developers in your company working on the development of a software before they are done, perhaps it's 2 years before they are done, 2 years. And then you count the salary of 6 developers every month for 2 years. You know what that means. Okay, whereas if you just went out and bought the software for $16,000, it's cheaper for you, except now you have to now pray and hope that the maintenance and support cost is not, over the moon. Okay, so yeah, customized software can take months or even years to deploy sometimes if you're making it yourself, because seriously, to develop a software, like the example I gave, just imagine the programs you've written as assignments, the programs you've written as tests and exams, multiply that by 1,000. Then you can realize what developing a typical software can take in terms of time, for example. Okay, now, waterfall system development process. We get into that. Waterfall system development process. The waterfall system development process, we say, please, it's important to take note of the description of this. We say it is a sequential Sequential meaning you have to go step by step. You can't count 2 if you have not counted 1. There is no way of jumping to 5 when you are still in 2. You must count 1. After you're done with 1, you count 2. After 2, 3, there is no jump possible. So we say it is a sequential, multi-stage system development process in which work on the next stage cannot begin until the result of the stage, the previous stage, are reviewed and approved or modified as necessary. That is one downside to this. You can't jump a step. And for every stage you complete, it must be verified and approved before you go to the next stage. There are 6 phases of the waterfall model. There are 6 phases. Number 1 is the investigation phase, followed by the analysis phase, followed by the design, followed by the construction, followed by integration testing. Investigation is just like, requirements gathering, meaning you want to develop a software for your company. What do they really need this software to achieve? So in investigation, you gather information, every information needed for the development of the system, what type of system you're supposed to develop, what it is supposed to give, what should be the input, what should be the expected output, what are all the facets, the legs and hands and everything that has to go into the system. That is what happens during investigation stage. Now that stage has to be completed and a report has to be produced for that stage. The report of, even before you start that stage of investigation, you and your team members have to sit together and pencil down or pen down all you want to do, how much time you think it's going to take you, and any cost implication that has to go into the situation. You have to put it together, present it for approval before you even go into such investigation. Then after the investigation, what happens is the result of the investigation gives you all the inputs you require for developing the software. Then you go to the next stage, which is analysis. Analysis involves extra work. Okay, like you are now analyzing what you've got, what you've gathered, with respect to what is expected. A form of analysis is done, a kind of thorough investigation, you interrogate what you've gathered as what is needed for the system to do. In this way, there is a kind of iteration, meaning repeating of things to make sure that you really got what was needed to be got. Then after you've done the interrogation of what you've gathered during the analysis, then you design. Hey, somebody's going to say design. Okay, now after design is construction. What is the difference between design and construction? Now, it's simple. Just like when somebody wants to build a house, on the average, except in some cases where people just go and then they tell the builder, okay, I need you to, they draw the line on the floor, okay, put a wall here, put a wall here, put a door here, put a window here. No, the average, a typical house before it is built, there is a design done for it. It is put on paper. The drawing is produced. So before you go into software development, which is now the proper work, you have to make a map of it. You have to design it on paper. Okay, that is where you have what we call the data flow diagrams, which then tries to capture all the parts of the software, where it should receive input, where the output should be, all that should go into it. Okay, that will be what you do during the design. You pencil it down, what you are going to develop. Then during construction is the actual design. You do the coding. Now it's easy to do the coding now because you already have developed the skeleton. So you go straight for each part of the code, each part of the program. You know what you're supposed to code for. You know how each part, works with every other part of the program. Then when you're done with the construction, next what you want to do is you integration. Now, it's one thing to develop an application. It's another thing to make sure that that application works with existing systems. You may go and inadvertently, like, maybe too ambitious, and yeah, you have the current Windows version is Windows 11. You may think, okay, yeah, Windows 11 is a good one, and you develop an application with your team that is only compatible with Windows 11. That means that your application is going to run on Windows 11. That could be, a very good thing to do, because after all, the company is moving forward. Now, when you're done with developing the application for Windows 11, you come back to the enterprise and realize that, oh man, there are still some systems here. There are still some computers in this organization that are running Windows 10. There are still some devices, that are still only compatible with Windows 10. And so they are not compatible with Windows 11. I told students in class that one of the experiences I have, somebody would have said, okay, you were not supposed to have it. No, anybody, especially when you're a busy person, can have some experience in IT. Several years ago, actually in the year 2009, I had bought a printer. I bought a printer. The printer was both a printer and a scanner. At the time I bought it, it was compatible with Windows 7. Before we got to Windows 7, I jumped Windows Vista. I had Windows XP running in my computer, and so I moved over to Windows 7, refused to use Windows Vista because it was problematic, and it worked well with Windows 7. My printer worked very well with Windows 7. And then when we had Windows 8, I moved over to Windows 8 in my computer, and the printer still functioned well. Now this is it. And the printer, because I didn't print a lot, I can tell you all that I didn't really print up to 200 pages of work from that printer, because I only used it very sparingly. After using it, I packed it until the next 2 or 3 years if I happen to use it. And so it was still brand new. And then now I moved over to Windows 10, and I had forgotten about what technology does. And I tried to connect this printer to my Windows 10 computer. It could not recognize it. The printer was compatible only as much as up to Windows 8. Goodness me, was still a brand new printer, not really used. Could pass for a new printer, but now I was using Windows 10. I couldn't use this new printer anymore. I had to give it away. So now, part of the integration is you're going to have to consider the new system you're developing. How well does it integrate with the existing system? How well does it function with the existing devices infrastructure in the company? If you develop an application that only works with Windows 11, whereas you have devices like printers, like scanners, like every other device in the organization that are compatible with the earlier Windows version, and perhaps this software is supposed to interact with such devices, then now you have a problem. You're costing the company more, because you're forcing them to go replace all their printers that perhaps are still brand new. So integration, testing, making sure that the system you're developing has integration with the existing system is very important. Then testing and implementation. Now, testing is a process. Of course, you can relate to that. You've developed a software, okay? Yeah, you need to test it. First of all, you do, unit testing. That's where the unit testing comes to, where you test it in one computer to see that it is functioning. After unit testing, you now, spread it out. Depending on the nature of the software, okay, you want to subject it to all kinds of pressures, both real and accidental. and see if it is able to withstand it, if it is still able to deliver what it is expected to deliver. That is the testing and implementation process. So now these things, but for the waterfall system, the 6 stage, we have the investigation, analysis, design, construction, integration, testing, and implementation. It should be easy for you to pick on any one of them and give a slight, some form of discussion on any of those points. And sometimes we require you to draw the picture. As you see here, you see each one is completed before the next one is started. It follows this way. And there is a loop in case the next stage there is a problem, it is taken back to the original, the previous stage, and work is done again before it's returned to the next stage. So it's important to look at this and then also capture this, commit this picture, this diagram to memory. So the waterfall approach allows for high degree of management control. That's one advantage it gives. High degree of management control. But then a major problem is that the users do not really interact with the solution until the final product is out. Users are not engaged in the development process. So the interaction is usually with the management, okay? So the disadvantage that users are not well integrated into the development process. And the result of this is that the user acceptance is very low, because if the users were not involved in the development, you're coming only at the final stage to give them what you think is going to work for them, usually there is a problem. It's not always well received. In addition, it lists at the table 12.1 lists additional advantages and disadvantages of the waterfall system development process. So I'm going to look at some of these advantages and disadvantages. And what am I pointing to? These are popular exam questions. What are the advantages of the waterfall development process, and what are the disadvantages? Okay. The disadvantage here, one of them says users can't easily review immediate products and evaluate whether a particular product will lead to a system that meets their business requirements. Remember, because they're only given the software when it is completed. So that's one disadvantage you get there. Okay, system investigation. What happens during this phase? Initial phase of the development of new or modified business information system, whose purpose is to gain a clear understanding of the specifics of the problem to solve or the opportunity to address. So we now have steps of the investigation phase. What investigation phase are we talking about? The very first phase of this development process. The very first phase, which we call the investigation phase. So what are the steps that are involved there? You review system investigation requests, identify and recruit your team members. You develop budget and schedule for investigation, like I mentioned. Schedule how long it's going to take, budget that you think, how much you think it's going to cost for that stage. Then you do the investigation, perform preliminary feasibility analysis to see if it's possible or not to get the project going forward, and then prepare a draft investigation report for the managers to see. Now, review results of investigation with steering team. Usually for big companies, you have this people set up: steering team, review system investigation request. There's a team called steering team who are responsible for looking at what you're bringing on board and approve or disapprove what you brought on board. The systems investigation requests includes preliminary statement of the problem or opportunity to be addressed, normal thing, a brief discussion of how this effort aligns with previously defined company and organization objectives, goals, and strategies. So whatever is envisaged to be developed as a software, there has to be a statement that shows how well it aligns with the goals and objectives and strategies of the organization. Okay, I mean, you're not going to go develop a system that's, for example, a software that helps some other type of business different from the type of business you are doing. Identification of the general areas of the business and business processes to be included in the scope of the study. You recruit the team members. Now, usually your team member will have a leader. In this same stage, you gather and analyze data. That is, you go over to the next stage. You gather and analyze data, prepare the investigation phase report, present results. Your team develops a list of specific objectives. The team establishes major milestones to help monitor progress. Budget is prepared, including travel expenses and funds. Now, this gather and analyze data is still a form analyzing of data within the first phase. Within the investigation phase, analysis is different. Sorry, I almost jumped. It's still within the investigation phase that you gather and analyze data within the stage you are working on. So you prepare budget, including travel expenses where necessary and funds for consultants where they are necessary, where they are needed. Then you perform the investigation. You may employ what we call joint application development in your process. You also do functional decomposition, a technique used during the investigation, analysis, and design phases. So functional decomposition, you see the statement made here, it is employed during the first stage, the second stage, and the third stage. You may find yourself performing functional decomposition. And what is this functional decomposition? There is a table here, a diagram here that tries to capture it. What is the software supposed to treat? Here we have an example that says stock management system is the name of the software. Stock management system. So what are all the parts of the stock management system that needs to be considered? For this particular case, there is the managed stock part of it, and also there is the managed suppliers part of it. Obviously, suppliers will supply the stock, and there has to be a system to manage what they supply. Then on the supplier side, you may need to add new suppliers in the software, update supplier data, or delete the supplier where such a supplier is no longer registered with the company. For the managed stock, you may have check stock, order stock, receive stock, store stock. This might be all part of what the software should capture. So this is an example of functional decomposition. Okay, then perform preliminary feasibility analysis. Perform preliminary feasibility analysis. And like I said, for feasibility analysis, we said that there are 5 feasibilities. We have the technical feasibility, economic feasibility, legal feasibility, operational feasibility, and schedule feasibility. For technical, you're going to be looking at whether the project is feasible within the current limits of available technology. You want to design something. I mean, it's not like building castle in the air. You want to design a software that is operational within the available technology. It doesn't mean that you may not develop your own technology if you have the capacity. You may even invent your own processes, but within what can be done, that is technical feasibility. Economic feasibility has to do with finances. Determines whether the expected benefits associated with the project outweigh the expected costs. You don't want to get into a project that the final result the benefit is less than the amount of time and effort and money that you put into it. Legal feasibility determines the legal boundaries of what you want to do. The legal boundaries of what you want to do. The software you want to develop, how legal is it? There's some software you may want to develop that are completely illegal, depending on the country you are operating from, okay? And I may not give a specific example, but they may not, you may just, as programmers, you know, programmers can do a lot of stuff, okay? If your software enables you, empowers you to hack into people's systems, even when they don't know it. Yes, you're using it for your company, but the potential for you to, you know, use it outside and then endanger another company or individual is there. So such an application that has the potential to hack into systems or spy on people, you know, might have some legal constraints attached to it. You know, the country may not allow you, may not let you do that. I mean, such an application may be used by the, you know, security services. It might be developed for them because they are the government, but you as an individual developing that for your private use may not be permitted. It doesn't matter whatever you want to do. Okay, so legal feasibility is checked. Operational feasibility is determining how a system will be accepted by people and how well it will meet various system performance expectations. The operation of the software within the company, how well received is it going to be, and will it really yield the expected functionality output? Schedule will be how long, determining whether the project can be completed within the desired time frame. You want to check, is it that this is going to take forever? You need the software to be out in 6 months. Is it possible to develop such an application in 6 months? Just an example. Then you now prepare a draft investigation report following all your findings. For systems analysis, one of the things that happens in this next stage is you must consider within this stage alternatives within identified constraints and investigating the feasibility of alternative solutions. This is one key thing that happens within the analysis, systems analysis. Then the primary outcome of the analysis is a prioritized list of system requirements and a recommendation of how to proceed with the project. Steps that you must take. Steps in the analysis phase will include identify and recruit your team members. Usually these are the same team members you started working with in the investigation stage. Develop budget, study existing system, that's the analysis. Develop prioritized set of requirements based on the information you got. Identify and evaluate alternative solutions. When we say alternative solutions, it is to say in reality, for every problem or any target achievement, there may be more than one route you might take to achieve it. So each option you may take to achieve the goal will be an alternative. So you identify all possible alternatives and then develop, evaluate the alternatives, the alternative solutions, evaluate them to check which one is the best. All of them likely have the potential to lead you to your destination, but then you need to do some analysis on them to find out, obviously, which one is best. They cannot all equally have the same, level of advantage for you. Then you perform the feasibility analysis to see, is it really possible, this alternative we're looking at? Is it possible to take us to the end, for us to start it and finish it? Then prepare your analysis report. Review results of systems analysis with steering team. Remember the team I said that has to be set up in a typical project environment. You go to design. After your analysis, the primary result of design phase is a technical design that details systems output, inputs, and user interfaces. That's what I didn't mention. I just gave you an example of the building plan that has to be used to build. Now, for your software development, the design involves putting in paper how you want the interface to look like, the user interface, okay? What the user sees, how should it look, the forms, the appearance of the forms. Behind the forms, you have your code. You can arrange your code in any number of manner, but then again, your code has to follow a certain pattern, okay? You have to indicate how each part of the code, interacts with other parts of the code. Identify and recruit your team members, get a budget, design the user interface, design security and controls where necessary, design disaster recovery program or plan, because for every software, every single software, in general, they produce data, they manipulate data, and the data that is manipulated or produced, there has to be a way to save it and also produce backup of that data. Design the database where necessary, and then perform feasibility analysis. Is it possible to build this plan we've made? You get into construction. That's where you go behind the real coding. Steps of system construction phase will include code software components, which is a software tool used to generate program source code. That is template-driven code generators, screen printers, menu creation software, report generator. But what is this construction? It's actually the coding. You now do the real coding to develop that application. Okay, you also have technical and user documentation, which is important. User documentation, that is a kind of step-by-step way to use the software you have developed. You create and load data. It may be necessary to write a program to read. These are examples of what can happen: to read data files from several sources, to reformat the data to be compatible with new systems, or to merge data sources together. Data for the initial loading of a new database may come from several sources, and just another story. Okay, we have a picture here which tries to show what may happen in a typical environment. Okay, here it says data for the initial loading of a new database may come from several sources, and that another program may be needed to edit the merged data for accuracy and completeness, and to add new entities, attributes, and or relationships. Okay, the database preparation task, creating and loading new data, could also be part of what you have to do. But in general, the construction is building the code, coding for the software. After that, after developing the software, you perform testing. Testing will involve unit testing, where you have an individual computer testing it in an individual system. Integration testing to find out how it integrates and works with other existing systems. Okay. Types of testing will involve integration testing, system testing, volume testing, user acceptance testing. So it's not just about the system. You also have to test how well received is the software among the users. So we have integration system testing. Then volume testing will involve evaluating the performance of the information system under varying yet realistic work volume. Okay, and operational conditions, like I said, you subject it to all kinds of stress, to the maximum stress possible, not only within the limit of what can be, go beyond the limit of what can be, to test its endurance. Determine the workload at which system performance begins to degrade, very important, by subjecting it to conditions greater than what it should take. You're able to determine that beyond this point, this software will break. Okay, beyond this point, this software will break. Eliminate issues that prevent system from reaching its required performance. User acceptance testing, UAT. UAT is testing performed by trained system users to verify that the system can complete required tasks in real-world operating environment and perform according to system specifications. That is what you have there. Okay? Then we go to the implementation part. Steps involved in this will be site preparation, installation, and cut over. Site preparation, installation, and cut over. For site user, within the user preparation, we have site preparation, installation, and cut over. For user preparation is a process of readying managers, decision makers, employees, and other users and stakeholders to accept what you have developed. Successfully introducing your information system requires a mix of organizational change skills and technical skills. User training is very important at this stage. Site preparation for a small system can be as simple as rearranging the furniture in an office to make room for a computer, to the removal of every existing system and replacing with new ones. Okay, installation process of physically placing the computer equipment on the site and making it operational. We get to the cutover that I mentioned before. This is a process of switching from old information. See, I highlighted it because, in real life, this is very important. This is very important. Have a situation over there in a government office where we submit building plans. Before December of last year in Johannesburg, any architect who had a plan to submit for a client, or maybe a client, you are somebody, a client, an individual, a homeowner, you've approached an architect who developed a building plan for you, he could do it, give to you, you just go there, submit the physical copies to the department for approval. Now, they changed the system from the manual system to everything digital. It meant that every plan that the architect had done for clients had to be scanned. I mean, some of these plans were printed in the largest format paper, A0. So you had to go look for a scanner that can scan A0 size paper into the computer, and then it had to be submitted digitally. Now, the system they developed to receive this, they were done with it, and then they gave a date beyond which nobody can submit physical copies again. Now they got to that date, and after that final day, the last day they received any physical copy was actually the 24th day of December last year. And so from the 26th, 27th, you had to go submit your drawings online. Now, but there was a problem. When they stopped everything, there was no manual submission anymore accepted. Everything had to be online. The problem was even the managers in the department, the staff, none of them was well trained for this work. None of them. They were all thrown into confusion. I mean, the department actually came to a grinding halt. It was like it was closed because nobody knew what was in this new software, how to use the software, how to access things in the software. Goodness me. Now, you see, one of the discussions I had with one of the managers is that we teach this in IT. What we prefer in such a situation is where we have cut over, where you have parallel cut over, in which case you have the old existing system still operational while you are operating the new system in parallel with the old one. So what happens is your work does not stop while you are also getting the experience in the new system. So those who would prefer to go the online will now go submit online. And while you are battling with the situation for the online submission, your work does not stop because you've stopped the manual submission. And so that's what an example of what cutover is about, a process of switching from old information system to a replacement system. Direct conversion, also called splunge, is a direct cutover at high risk approach, meaning you are just changing from old to new with nothing in between. The phase-in approach is another one, which is piecemeal approach, involves, now please, this is one of the examinable questions. Cutover, describe all the, at least 3 types of cutover or all the types of cutover you would know. The first one is direct, where a system is changed from old to new with nothing in between. It's direct changeover. Piecemeal approach involves slowly phasing the new system's components as the old system components are phased out. That's another approach that the department could have used. Leave the old to be running, bring in the new, gently bring in the new. Things are running, okay, side by side somehow. You are reducing the number of copies of plans you receive per day, using the old system, and increasing the number of plans you receive per day using this new system. And so when people see that there's pressure on the old system, they are now forced to go to the new system, but then work does not stop because people have not yet understood the new system. So this will be called piecemeal approach, phase-in approach. Okay, the other one is pilot startup, running a completely new system for only one group of users. That means go to a particular office and implement that while the other offices are running. Parallel startup is another one, meaning running both the old and the new, which I suggested to the manager in the department that it was better you run a parallel system. So just divide up the staff into 2 groups. One group should be taking care of the new system, new way of doing things, while the other group stick to the old. Then after, you can swap them, and eventually you can now close the old system when everybody had become acquainted with how the new system works. This is real life. Okay, so that's what we get there. Then system operation and maintenance steps. System operation and maintenance steps. We have the operation when you start using the software. Maintenance, you have to maintain the software once you start using it. Disposal will be where you want to just stop using the system and discard everything about it. Now, operations involve the new or modified system under all kinds of operating conditions. A formal help desk is beneficial for employees and customer monitoring and customers. There should be full stop here. Monitoring involves measuring system performance by tracking the number of errors encountered, the amount of memory required, the amount of processing or CPU time needed, etc. There is system review, which is a process of analyzing systems to make sure they are operating as intended. This comes under operations. Maintenance will be, there are some reasons for maintenance, where the system is performing poorly, where there is a change in business process, where changes in the need of system stakeholders, users, and managers, where there are changes in those areas, where the system has got bugs or program errors. Okay, it could also be technical and hardware problems, corporate mergers and acquisitions, changes in government regulations, changes in operating system like from Windows 10 to Windows 11, slipstream upgrade, patch, release, version. These are all some of the reasons for program maintenance. Disposal, what is it about? System disposal involves those activities ensuring the orderly dissolution of the system, and the steps involved will include communicate intents to dispose the system, terminate contracts, make backups of data, delete sensitive data, dispose of hardware. Dispose of hardware. Now, this is where I am going to call it quits for today. I know somebody might have been actually rush the system somehow. Somebody may have been wanting or wondering, when is John going to stop talking? He's been talking for the last almost 2 hours. I wish he would stop now. Now you have it. Okay, I'm going to let you go now. But please, I'd like for you to mark where we are at now. What's her name? Bianca? She's gone to sleep. Bianca?
I'm still here.
Yeah.
Yes, John.
You're going to have to remind us in the next class where I stopped.
Will do.
We're going to start in the next class with agile development. So mark that position. So in the next class, we continue from there. In the meantime, I'm going to stop recording.